Hi all. This 10-15 minutes video talks about one-dimensional vectors. We'll start with what vectors are, how are they different from arrays, and how do we initialize vectors in 2 to 3 different ways. And then we'll see 5 methods that are core or essential when we are working with vectors in C++. So let's get started. So the main reason why we have vectors in C++ is that arrays are static in nature. So that means whenever we are creating an array, we have to tell the C++ compiler the size of the array. And the moment we tell the C++ compiler, it will allocate 10 memory blocks for that array and so on. So that means once we tell the compiler that, I want an array with these many number of elements, that means we are done with we are done with initializing the array, and we have to live with that array throughout the program execution or throughout the C++ program course. That's the problem with arrays. I cannot dynamically expand it when the program is running. I have to tell all the required number of elements or everything related to array at the time of compilation. And when it comes to runtime, all we can do is to access array, but cannot increase the elements in array. So this thing is something like static nature. That means if I tell the size of the array, I'm fixed with that size throughout the program. I cannot do anything to increase the size of the array. And to solve this problem, we have vectors in C++. So the opposite of static is dynamic. That means which can be expanded while the program is running. So when the C++ program is in execution or running, we can reduce the size or expand the size of a vector. That's the advantage. So with vectors, we can dynamically play around with the size of the vector or the number of elements inside the vector. This is a limitation of arrays, but this is the advantage of vectors. Now, let's start with one-dimensional vector. In order to work with vectors, we should include the vector library in C++. So we should include this. This is a must. Now, there are 3 types of initializations. The first one is like telling the vector size and then using a for loop to initialize the elements. So the way we declare a vector is we start with this keyword called vector. This is an indication to the C++ compiler that we are about to create a vector. And then we have angular brackets. In this angular brackets, we'll define the data type. So these two together, vector, angular brackets, int, are an indication for the C++ compiler that I'm about to create a vector of integer data type. And then we will give whatever the identifier name that we want. In this case, I'm giving an identifier name of vec. This is how I'm gonna call or refer my vector. And then instead of square brackets that we used in arrays, we use circular brackets when it comes to vectors. And now within these circular brackets or parentheses, I'm about to define my vector size and then a semicolon. So this is a keyword, you can say, not exactly a keyword. This is an indication to C++ compiler that we are about to create a vector. This is the data type, and we can create a vector of integers, vector of float, a vector of characters, strings, Boolean values, double two. So all these are legal. We can create vector of all these data types. This is the identifier, and this is the size of the vector. So this is how we create a vector. In the first approach, we just have created the vector. Now what we do is, as soon as we create a vector, size is allocated or space is allocated inside memory. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So a vector of 10 elements is created. Now, the starting index is 0, the ending index is 9, which has a starting point, which has an ending point. This makes a perfect case for creating a for loop. Start with the starting index, go all the way till ending index plus 1. So that means we are going till the ending index. And for accessing the next element, just do increment of it, and then simply see out, or no, sorry. We are assigning the values to vector. So vector of I. So when declaring vectors, when initializing vectors, we use parentheses or circular brackets to specify the size. But when accessing the elements, we are back to the way we access an array or elements inside an array. So here we are initializing a vector with I values. So that means this vector is going to contain data between whatever the index is there, the same thing is going to be inside the vector elements. So this is how we just created a vector. This is the first approach for creating a vector and populating the vector with contents. Now let's see the second approach. In the second approach, we can give all the elements a single value. Like for example, start with a vector keyword. I want to create vector of integers. And let's say I'm going with the same identifier. I want 10 elements. This time, I want all the elements to contain a value 1. So that I will give inside the parenthesis with a comma. So that means I'm creating a vector of 10 elements. So 0, 3, 4, 5, 9. And the contents of all these elements are going to be 1. So this is how we create a vector with all the elements as 1. This is while creating the vector itself, we are populating the vector with all the elements. Now in the third approach, instead of specifying the number of elements we want, we can directly specify the elements of the vector. So we won't be giving the size of the vector. So we will be giving the elements of the vector. So when we are only giving the elements of the vector, we are back to, or we will be using curly brace or our scope indicators. So vector, remember there's no size. I'm only giving the elements. So this means I am creating a vector with 10 elements, and the elements are going to be so the elements are going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is how, the 10th one, 9 and 10. This is going to be 1. So this is how we created a vector of 10 elements without giving the size. So these are the 3 different ways we can give. Give the size, use a for loop to initialize the elements. Give the size and also the default value so that all the elements will be populated with it. Do not give the size, just give the elements, and C++ compiler will take care of the rest. So these are the three ways in which we create vectors in C++. So if we see here, this is the first approach in which I'm creating a vector. I'm just giving vector followed by the size, and then I'm using a for loop to create all the elements, and then I'm printing again using a different for loop. In the second approach, I'm using a default value where all the elements will be ones. And so yeah, this is the output of the second approach. All the elements are ones. In the third approach, I'm specifying the default values or the values of the vector by default in the initialization step itself. And I'm using a for loop, and this is how the output is going to look like. Now we'll see some of the methods of vectors. So vectors in C++ are composed of 5 methods. So these 5 methods are something that we are going to extensively use it. So the first method is size. Remember, we do not have a way to find out the size of arrays. We are forced to define the size of arrays with a constant variable or identifier, and we were using it as reference. But unlike that, we have something called as size operation in vector that gives number of elements inside the vector. In vector. So this is the size operation. Next. Remember, we said that vectors are something that has dynamic capabilities. So that means while running the program, we can remove an element from the vector, we can remove some space, we can add some more space and add some value to it. So all the operations that are concerned about adding something to the vector, we call it with the term push. So push means add or insert something. So the second method is push back, and this method takes whatever the element that we need to add to the vector. So for example, if vec is my vector, I will be adding a value 10 at the end of the vector. So let's say if I have 10 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the vector state. The moment the compiler runs pushback, it goes and inserts a value 10 at the end. This is the meaning of pushback. Pushback will accept whatever value that needs to be inserted into the vector. And the third method is pop. And remember, anytime we are talking about pop in computer science, that means we are asking to remove an element. So in this case, the vector method is pop back. So for removing an element, we don't need to specify anything. We can simply say pop back. So if we call vector dot pop back on this vector, then the C++ compiler will remove this element. So the whatever the size when we ran the pushback, initially it was like 40 bytes. The moment we ran pushback, it changed it to 44. So the whiteboard is stuck. So the moment we change the size of the vector, it kind of, the moment we did something like pushback, it changed it to 44 bytes. And the moment we run the pop back, the element gets deleted and vector size is back to 40 bytes. So this is the capability that vectors has, where arrays do not have in C++. Now, the fourth method is, what if we want to remove all the elements from the vector? So we have something called as clear method. So vector dot clear will completely remove the vector, and the size for this vector is going to be 0 bytes now. And lastly, the fifth method is to check whether a vector is empty or not. So checks whether a vector is empty or not. So this is the empty method. If the vector is empty, in this case, our vector is empty because we just called clear. If the vector is empty, this will return 1. If the vector is not empty, then this will give 0. So depending upon whether the vector is empty or not, that method will give 1 or 0. And now, in this file, I have created a vector with 5 elements. I'm populating them using a for loop. Now I'm printing them using the same for loop. So if we see, I just created a vector with 5 elements. Now I'm calling, and if we see, I'm making use of the size method. I'm no longer specifying less than 5. So I'm calling the size method. Size is going to be 5. And I'm asking the vector to push, I'm pushing a value of 6. So the moment I'm pushing the value 6 to it, this is how the vector state is going to be. A new element gets added. And then again, I'm accessing through size only dynamically. I'm not specifying the size like with, no longer we are specifying with hard-coded numbers like 5 or 6. We are following a method. Now, pop back means remove an element, and I kind of ran pop back twice. So both 6 and 4 are removed now. So the vector is now going to contain 0, 1, 2, and 3. Now, lastly, I've just printed the elements and I'm calling clear. Clear means all the elements inside the vector will be removed. So when I called clear, the size says that there are no more elements inside the vector. And lastly, I'm checking whether the vector is empty. If the vector size is 0, that means it's empty. So the if condition is true and we are printing vector is empty. So this is how we make a use of all the 5 methods in vectors. And this is the picture about one-dimensional vectors.